Hello again everyone, welcome back to ptet.chemistry channel. So in this lecture tutorial, we'll continue these calculation questions on reacting masses and the idea of using a cross multiply in our calculations. But the most important thing in this kind of questions is basically calculating MR. Remember what I talked earlier, MR is basically for one formula unit. So basically when you have one in front of the formula, but when you have two or three, you have to multiply the MR by the number in front, basically how many of that formula unit you have to calculate the reacting masses of the reactants reacted or the products formed. So here very clearly we have 1 unit and we have 3 units. We have 3 units and 2 units of that. We have this equation which is balanced, but we don't know what is X. You see, we don't know what is X. We know the relative molecular mass, which is basically what they're saying, MR. So the MR of X2O3 is 152. Remember again and again, MR is for one formula unit. Only for one formula unit, that means when one is in front. But we are mainly concerned ourselves about something called reacting masses. What is the mass that actually reacted and also formed? That's why this topic is called reacting masses. When you have 1 in front of it, so that means 152 is for 1 unit, and when you have 1 unit, you have 152 gram. So 1 unit of X2O3 has a mass of 152 gram. The unit, well, there's 3 mg here, but the relative atomic mass, basically for 1 mg, this is for 1 unit. So for 1 mg, it is just 24. So when you have 3 mg, you will have 3 times 24. So this give me on my calculator 72 gram. So on the left hand side, I have 152 gram of X2O3 reacting with 72 gram of it, and altogether the total mass on the right must be equal to the total mass on the left, because that's the meaning of balance equations. You can also not create, you do not create nor destroy matter in a chemical reaction in chemistry. That's what we do. We're just converting the matter from one form to another. It is not sorcery or witchcraft, but it is rather science and chemistry. So here, the MR of MgO. MgO, the MR, it has 1 magnesium and 1 oxygen, so there's 24 times 1. So I'm just looking at 1 unit, which is just MgO. The MR of that is going to be the 24 for each magnesium, and there's 1 of it, and then I sum it up, so there's 16 times 1 for the oxygen, and I get 40. This was part of your work 2, work 4 if I'm not mistaken. MgO was asked in that exercise, but I have got 3 of it, so my reacting masses is going to be 3 times the 40, giving me 120 gram. Now the AR of X, this is what I don't know. I don't know the AR of X. So if I let the AR, so let the AR of X be, I don't know, Z for example. So if I have a number which I don't know, let's say Z, but I have got 2 of it. I have got 2 of the X. So my reacting mass will be 2X gram. So what do I know here? I know that the sum of the masses on the left must be equal to the sum of the masses on the right. This is mass because the AR for 1 of the X is Z, and I've got 2 of it. Sorry, shouldn't be 2X, it should be 2Z. Okay, so what I can do is I can do a math. 152 gram plus 72 gram on the left is equal to the sum of the mass on the right. So what do I know? I know that 2Z equal to 152 plus 72 minus 120. So 2Z is equal to 152 plus 72 minus 120, that is 104. So what can I do? Well, if 2Z is equal to 104, so what is Z? Z is 104 over 2, and I get 52. So that has got to be 52 there. That is the relative atomic mass is for 1 unit of that, which is why I multiply by 2 here, and I do this reacting mass equal sign, because everything on the left sum up to everything on the right. Now use the periodic table to identify the element X. Remember how to read the periodic table. Relative atomic mass is not the proton number. So if you go to your periodic table, let me just go to my periodic table. Gotta find my periodic table first. Where is it? Okay, so if you find your periodic table, you will know that something on top and then something at the bottom and something at the bottom there. So in your periodic table, the relative atomic mass or the AR is given at the bottom, as that's what the legend or the key in the periodic table actually show you. These are the protons, or what you call the atomic number on top there. So look for an element that has got around 52 and that has got to be chromium. Okay, so I found this thing from the periodic table by looking at relative atomic mass, AR, not protons or atomic number. This goes back to your atomic structure topic. If you know how to read the periodic table, you get the 1 mark. Now what do we know? We want to find the mass of magnesium that reacts with 152 gram of X2O3. So the X2O3 is 152 gram. What is the mass of magnesium that will react with it? Well, there's 3 magnesium that reacts with it. So we already calculated 3 times 24. So the answer there must be 72 gram because we have done all the hard work. The calculation is similar. They can just ask you using different words, but they can be filled in the blank as well. It's the same kind of idea because 152 gram reacted with 72 gram, giving you this much gram of MgO, and 2Z, which is 2 times 52 gram of that X there. Use the answer to B part 1. Use the answer to B part 1 to calculate the mass of the oxide that reacts to 3.6 gram of magnesium. So they want you to use your answer to B part 1. So what we can do really is, let's try this. What we have is magnesium. So 3 magnesium giving us, 3 magnesium reacting with the oxide, meaning the X2O3. So X2O3 and 3 magnesium. So X2O3, 1 of it, reacting with 3 magnesium. What else do we know? We know that 72 gram of magnesium. Oops, actually, am I correct? Yep, okay. 72 gram of magnesium reacting with 152 gram of X2O3. That is from the reacting masses above. I'm just simply writing down what I had done previously, so nothing new at all. Reacting masses is not just looking at the MR or the AR, but it's considering the number in front because it's the total mass. For 1 magnesium, the mass was 24 from the AR in the periodic table, all as given here, but 3 of them give me 3 times 24, 72 gram. So not a big problem here, but they want us the mass of the oxide. So the oxide is the X2O3. I don't know, I just put down Y. I could put down Z, I could put down X. It's up to you what you put it down there. And I want it to react with 3.6 gram of magnesium. So I'm doing a cross multiply here as well. So what happened here is, let's start cross multiplying. So that and that, so 152 times 3.6, this is equal to the other side of the cross multiply, which is Y times 72, or 72 times Y, which is just 72Y. You could do Y times 72, which will also give you 72Y. It is just mathematics. So Y equal to 152 times 3.6 divided by 72. So what happened then is, well, I get 7.6 gram if you press your calculator correctly. So there's 7.6 gram of the oxide that will react with 3.6 gram of the magnesium. This is down to something called ratio or proportions, something from primary school as well as lower secondary mathematics. You must be able to do this kind of cross multiply correctly. We don't put in the G because there's just a unit in gram, so our Y comes out as gram as well. We're just concerned ourselves with cross multiply, so this times this number equal to this times this number, and therefore we just make Y the subject because this 72 times Y, 72 moved to the other side is divided by 72. Using your answer to B part 1 was basically the relationship there, which we have just calculated previously. Alright, so I think I've just got one more example to show you. I'll connect it in the other video. You don't have it in your notes. If you want, you can copy it, but if not, it's really up to you. Okay. So question 3, we have a simple reaction, sodium plus chlorine to give you sodium chloride. So what happened here is straight away they tell you the MR of sodium chloride is 58.5, so you don't need to calculate it again. Remember, MR is for one molecule or for one piece. Okay, so when you have 2 in front, you need to be careful. So reacting mass means you need to consider how many of it do you have. Obviously, we don't talk about molecule for sodium chloride because it's ionic. That's why I say one formula unit. Perhaps I can say 1 molecule or 1 formula unit. 1 formula unit, because that is also the term used in your syllabus, relative molecular mass for 1 formula unit. This is for 2 formula unit, so you can say the reacting mass. When I talk about the reacting mass, I have 2 times 58.5 gram. So 2 times 58.5 will give me, oops, that is wrong, give me 1/17, that's gram. So CO2 comes from 35.5 times 2. So 35.5 times 2 will give me 71. And I have 1 of it. So my reacting mass is 1 times 71, which is equal to 71. So I can do that to show you 71 because there's only 1 of it. Sodium, each sodium is 23, but I've got 2 of it. So 2 times 23 will give me 46. So altogether, you got 46 gram plus 71 gram. So 46 plus 71 gram give me a total of 117, which is actually a result of 2 of this NaCl. That's why I have to do 2 times the MR to give me the idea of conservation of mass. Everything from the left will give me everything on the right. Balancing equations, reacting masses. Now, if we go back to the questions, so they say 46 gram of sodium. So I already know 46 gram of sodium comes from 2 Na because I've done the calculations. So reacts with how many gram of chlorine? This is from the balance equation. This is from the relative molecular mass multiplied by the correct multiple based on what they have said. There's 46. So here 2 reacts with 1 of these, meaning 46 gram of sodium reacts with 71 gram of Cl2, and they will give you 117 gram of NaCl because I remember to multiply that by 2 since it's only for 1 formula unit. So there's 117. That's the easy bit to the question. The more difficult bit to the question is when you have 4.6 gram of sodium. Now you want to know what is it with the chlorine. So if you think about it, the sodium is to the chlorine. If I write it a lot better, so I've done this cross multiply a couple of times previously. You can use other methods like the ratio method if you want to, but only if you know what you're doing. Okay, 46 gram of that Na give me, well, will react with 71 gram of CO2. All right, from the equation. Now you have 4.6 gram. So if you have 4.6 gram, then what is X? Well, you cross multiply. So 46X equal to 71 times 4.6. X equal to 71 times 4.6 over 46. So press that onto your calculator and you get 7.1 gram of CO2. I get gram because I started with gram there. So 7.1 gram of CO2 is going to be my answer there. How about sodium chloride? We go back to our equation. We relate back the sodium and the sodium chloride. So sodium, the 2Na going to the 2NaCl, the 46 gram giving me 117 gram. So 4.6 gram give me how many gram of these? So cross multiply. 46Y is equal to 117 times 4.6. Bear in mind that the G there refers to the unit. They are not quantity, they're just units. So I just ignore the units now. Y equal to 117 times 4.6 over 46. Press that onto your calculator and you get 11.7 gram. So I get 11.7 gram. So this question is a bit long. So now they want to talk about 1.15 gram of sodium. So I'm going to do exactly the same as that, but instead of 4.6 gram of Na, I will use 1.15 gram of Na. So it's the exact same method. So you shouldn't get confused or anything, provided you know how to start the question. So you got 1.15 gram of sodium. So I call that Z now. So let's see. So cross multiply. So 46 and Z, 46Z equal to 117 and 1.15. So 117 times 1.15. The Z equal to blah 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 divided by 46. And I get 2.925 gram of that sodium chloride. So hopefully that makes sense there. So thank you for watching. Don't forget to click the button on the bottom right to subscribe to the channel and share the channel widely with other people you know who might benefit from these tutorials on the channel. Okay, see you in the next tutorial video. Thank you for watching.